First of all, welcome to XSI Particles in Practice. I am Human Behnasi, and in this volume, Volume 1, we will be covering the fundamentals of XSI particles through a series of real-world samples. We will start firstly by talking on how particle phenomena are defined in XSI. In XSI, each particle system consists of a bunch of technical parts that control two main aspects. The first one is the particle's behavior, which is the way the particles move and interact in our scene. The second aspect is the particle's look, which is how they are going to be rendered. If we take a look now on a standard particle system in XSI and view its components in the Explorer, we will notice that it consists of two objects, the emitter object, which is a standard geometry object, and the cloud object, which is a special container object. Now under each of these, there are a bunch of properties and operators that are used to control the particle system. If we expand the cloud object in the Explorer, we will find firstly a particle cloud primitive. Directly under it lies the particle operator. This operator is used to execute and control the particle simulation. In XSI, there are three types of operators that can be created. To view them, we will switch to the simulate module, where we are going to spend most of our time when working with particles in XSI. And under the create particles, there are a group of commands for creating particles with special operators, such as the group here for creating particles with a fluid operator, and the group here for the explosion operator, in addition of course to the standard particle operator. To view or edit any of these operators without opening their PPGs from the Explorer, we can select the particle cloud and use modify particles edit simulation. This will open the operator property page for the selected cloud. Let me open another operator for a fluid-based cloud. Now notice how each operator here has its own unique sets of parameters that control the simulation. For example, the fluid operator here has accuracy, slave ratio, foam percentage, and other parameters that are not found in the standard or the explosion operators. We will be explaining most of these parameters while doing the samples later. Now let's close these PPGs and continue digging in the Explorer. If we expand the particle operator, we can find two properties underneath it. The first that I'm selecting now is the emission property, and it contains all controls that are required to define our particle emission, such as rate, spread, velocity, etc. So it cooperates with the particle operator to define the behavior of the particles. Okay, to open its PPG, we can also select the cloud and use the inspect emission and select the emission property from there. Accessing different particle components from these menus is a big time saver because it saves us from digging deep in the Explorer each time we want to edit one of them. Okay, the second property under the particle operator is the p-type property. And this property here is where we can edit and control the final look of our particles, such as their color, size, shape, etc. In addition to some simulation parameters like those found under the environment, noise, interparticle, fluid and explosion tabs. Also, we can access the p-type PPG from the inspect particle types menu. Now the special thing about p-types is that we can expand them using shaders in the render tree like any other surface in XSI. So if I press 7 on my keyboard and open the render tree for the current p-type, we can notice how there are two shaders connected to this p-type, the particle billboard and the particle shape shaders. Each one of these shaders has its own input ports that can be connected with other shaders. This allows more control on how the particles will be rendered. Now if we return back to the Explorer and expand the emission property, we will find that the p-type is underneath it also. This means that this emission property will emit particles with this particular p-type. Okay, now if we go to the emitter object and examine it, we will notice that it contains the same emission property. What a big surprise. Let's guess now what's under the emission property here. Of course it's the p-type property. So this means that we can access the emission and its p-type either from the cloud or the emitter object. So these are the only internal components that define a particle simulation. And I named them internal because there is a list of additional objects in XSI that affect our particle simulation, and they are not directly part of the particle cloud. At the top of the list of these additional objects are forces, where we can add and combine any number of these available forces to control our particles in physical and natural ways. Other additional objects or components that affect particles are obstacles, goals, and events that can be used to make the particles interact with the rest of the scene using either physical or logical ways. We will learn more about all of these stuff later as we deal with them in the samples. For now, I would like to summarize the particle components we talk about in XSI using this simple diagram. If we take a look here, we can find the two main objects we talked about, the cloud object and the emitter object. We can see then the different operators that can be used to control the simulations, which are the standard particle operator, the fluid operator, and the explosion operator. Next is the emission property, which can be accessed either from the cloud object or from the emitter object. And as it says, it controls all emission parameters such as the rate, spread, velocity, etc. Under it directly is the p-type, which is mainly used to define the look of the particles in addition to some simulation parameters. The p-type also is extended with shaders in the render tree and used to localize and control additional components like forces, events, and goals. Okay, in addition to all the previous control options that we have, XSI gives us the ability to deal with particles like any standard geometry. So we can move its points manually as we do with geometry objects and apply deformers to it with any combination we want. Now the next thing I want to introduce in this lesson is the places where we can access and view the different particle parts that we have talked about previously. We will take our simple particle system and continue with the Explorer. As we all know, the Explorer in XSI is a great place to view and access different parts of our scenes, including particles. The special thing that we can use the Explorer for here is the particle types scope. This scope lists all particle types available in our scene. Of course now we have only one particle type, but it's really common to have a dozen of particle types in a scene when doing complex effects, and that's when this scope becomes more handy. A second place that plays an important role when dealing with particles is the schematic view. Now the schematic view in XSI lists all different objects in our scenes, such as scene cameras, lights, 3D objects, and others, in addition of course to particle objects. But we can customize it a little bit to make it give more relative info on our particle systems. So from the show menu, I'll check the simulation and simulation links options to view all objects that relate to the selected particle cloud. Note how all particle types, emitters, forces, etc. and the relations are now shown between all related objects. Honestly, I depend a lot on the schematic when editing complex particle systems, because here I can access and edit any property on any related object without digging in the Explorer. So for example, when I want to open and edit the emitter property, all I need is to select the emitter link from the schematic and hit enter on my keyboard to open its PPG. The same thing goes for the particle operator. Another place that can be customized like the schematic is the 3D viewports. So if we switch the relation option in the camera view, we can see all relations between particle objects in a very similar way to the schematic. But again, my personal preferences go to the schematic because it shows these relations in a cleaner and more abstract way. Okay, that completes our overview on the particle system structure in XSI. It can be confusing at the first, but as we advance with the sample, it will make more sense for us. Thanks and see you on the next lesson.